If things look a bit different this week, it's because I'm recording live from the set of Hangout-a-Thon 2023. Erik will be recording remotely because his schedule didn't allow travel this weekend. But for my segments, there may be occasional chaos. This year's Hangout-a-Thon is focused in on raising funds to support this show and all the other shows we produce at CosmoQuest. Over 32 hours spread across 3 days, we're recording interviews, playing games, spending time with some musical guests, and otherwise working to celebrate science as we record content you'll see during future episodes. This is your reminder. We would do this show for the love of doing the show if we could. But because we have bills and like to eat, we ask that if you are able, please consider joining our Patreon community or making a one-time donation through our website. If you join our Patreon at patreon.com/CosmoQuestX for even just $1 a month, you can get ad-free content, early access to videos, and bonus features. We just want to help you learn and do science and release accurate information under a Creative Commons license that lets it be played in schools and clubs without any copyright concerns. And now, I'm going to focus on the science. This week, we bring you news of Mars quakes, black holes, and how merging stars make heavy atoms. We also look at stories from the launch pad with aerospace correspondent Erik Madaus. All this and more is coming to you right here on Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. One of the awesome things about growing older as an astronomer is you get to see the weird stuff no one understood in your youth become the everyday normal of your middle age. While we still don't understand things like dark matter or the accelerating expansion of our universe, I'm really enjoying the evolution of our understanding of gamma ray bursts. First discovered in the 1960s. The only things we knew for certain when I started in astronomy were some bursts lasted up to several minutes, while others lasted only seconds or less. While that is information, it wasn't satisfying information. Over the decades, we've come to learn that gamma ray bursts are triggered by at least 3 different phenomena, including the merger of neutron stars. These wild events light up detectors of all kinds, with everything from gravitational waves to light of most colors, all slamming into our world at once. These kinds of mergers have been theorized for a long time, but it was only in 2017 that one was finally observed, allowing researchers to confirm these mergers are one of the largest producers of heavy elements like gold. In March of this year, 2023, a 200-second-long gamma ray burst called attention to the merger of 2 neutron stars. As the massive yet tiny dead stellar cores came together, they created a hot, high-density environment where atomic cores, neutrons, and fragmenting atoms could all slam together. This event was spotted by NASA's Fermi Gamma Ray Space Telescope, which, along with collaborating ground-based telescopes, measured its location with an accuracy sufficient to allow controllers to point the JWST at the explosion. In infrared light, they made out a distant pinprick called a kilonova in the outskirts of a spiral galaxy 120,000 light years away. Using a spectrometer, they were able to split the kilonova's light into a rainbow and look for the specific dips and peaks that indicate what elements are present. For the first time ever, they identified features associated with the atom tellurium. On Earth, this atom is more rare than platinum and is necessary in a number of manufacturing processes, including the tinting of glass and ceramics, as a catalyst in oil refining, and in the construction of solar cells. This means an ingredient in our planet's modern technology is born in the death of two stars. We are, after all, nothing more than star stuff. It's just wild what has to happen to create the diversity of atoms needed to create our wild world. Pairs of objects are responsible for some of the coolest phenomena in our universe. And while a lot of these pairs end up merging into a single object given enough time, there are a few, theoretically at least, that the universe carefully holds apart. In a new paper in Physical Review Letters, researchers led by Oscar Diaz explore the possibility that our universe can precisely balance the desire of gravity to pull black holes together against the ability of the universe's expansion to pull them apart. I was a physics professor for many years, and I have to admit, if I was teaching graduate relativity, I'd have a new favorite homework assignment. Our reality is defined by the interaction of balanced and unbalanced forces. As I sit here, gravity pulls me into the floor and its structural integrity pushes back up in the form of a normal force. The forces are balanced and there is nothing to accelerate me into the air or drop me to the floor. Anytime you have multiple forces, you know it's possible, if you work hard enough, to figure out just how to balance things. In their models, they envisioned the simplest of systems, two non-spinning black holes. The physics doesn't care about a specific size, it just cares that they are matched. They do look at the case for smaller black holes that don't have the same physics associated with their surroundings. They find that it is possible to perfectly balance things across time and space, so the two systems will stay for a time at the same separation. This isn't a forever kind of thing. Too much is constantly happening at the event horizon of black holes, and this balance just isn't stable. But for a time at least, two black holes can balance in space, maintaining a constant separation. And we will most likely see their lack of light and massive combined gravitational pull as coming from a single object. For all we know, we've already seen this kind of a balancing act and we just didn't recognize it. But probably not. As I said, their work considered non-spinning black holes that are nicely identical. It is possible to expand this work out to include non-identical systems and spinning black holes. But that is left for future work that I, for one, look forward to reading. To succeed in astronomy, you really need to be either really, really good with technology or really, really good at math. I personally am a technology person, and I'll happily operate telescopes and write software. But I'd really not like to do the seemingly endless juggling of variables and constants that goes into theoretical work. Luckily, there are actually folks out there with both the aptitude for maths and for computing. And it is one collaboration of these folks who have just brought us the new highest resolution model of our universe and its evolution over time. This work is described in 3 papers in the monthly notices of the Royal Astronomical Society that address methods, the simulation's results, and a comparison of those results with our reality. This is one of the first models to consider both cold dark matter, which is the primary component of our universe, and also the regular baryonic matter like we're made of, and also neutrinos, which honestly, they aren't exactly regular matter and also aren't cold dark matter. Past models left out regular matter because it is affected by gas laws and particles can build up into structures and otherwise interact in ways that are just a lot more complicated to model. It was hoped that by adding a richer diversity of materials, they would be able to bring the models into enough alignment with reality that we can start to understand why our measurements of the physics driving the universe's expansion are inconsistent when we look at the early universe and the modern universe. While this simulation, called Flamingo, does better than past simulations at matching our universe, it still doesn't have the level of detail needed to allow us to know where our understanding, where our model goes just slightly wrong. It's a start, however, and the improvements being seen indicate we're on the right track. It allows us to track how the temperatures of gas, distribution of dark matter, and emission of X-ray light all track together, and how effects like galactic winds play their own part in evolution of our universe. To do better, we're going to need more powerful computers. I can only hope that with the constant advances of processor speeds, simulations like Flamingo will soon allow us to go, oh, that's where our equations are missing something, and figure out what factors are actually forcing apart our expanding universe. After a break, we're going to zoom in on our own corner of the universe and look at objects in our solar system, including brand new images from the Lucy mission of a little asteroid called Dinkinesh. Stay tuned. Back in October 2021, a mission called Lucy lifted off on a multi-year journey to visit Jupiter's 2 collections of Trojan asteroids. Today, it's making its way through the asteroid belt before circling back to use the Earth to get a gravitational assist in 2024. While the asteroid belt is mostly empty space, researchers will go out of their way to match spacecraft trajectories with asteroid orbits to try and make sure no spacecraft passes through the belt without seeing at least one asteroid, or maybe 2, or maybe 3. On November 1, Lucy flew past the asteroid Dinkinesh, discovered in 1999. This system is about 0.7 kilometers across. It was seen to vary in brightness, and it was assumed to be just rotational effects. As Lucy got closer and closer to this distant space rock, researchers began to wonder if maybe, just maybe, they were actually seeing light from a second asteroid orbiting Dinkinesh like a moon or a binary asteroid. And in the November 1 image, we clearly see Dinkinesh has a friend. Estimated to be about 220 meters in size, this companion is still unnamed and turns out to be 2, possibly touching, and represents one heck of a lucky find. In a quote that pleases my Gen X heart, Principal Investigator Hal Levinson explains, quote, "When Lucy was originally selected for flight, we planned to fly by 7 asteroids. With the addition of Dinkinesh, 2 Trojan moons, and now this satellite, we've turned it up to 11, end quote. After that quote was released, the moon, it turned out in a second image that came down, is probably 2 objects. Yeah. Once upon a time, we thought asteroids were just bland rocks. Turns out, if you actually look at them from up close, they are complex and interesting and come with friends. When the Dawn mission visited the largest asteroid series, it discovered ice volcanoes and a geologically diverse landscape and complex organic molecules. How the kinds of chemistry necessary for life can end up on a very beat-up, icy, inhospitable world is a bit of a mystery. And scientists are here to solve mysteries. Researchers at the Geological Society of America Connects meeting presented new research that compares the locations of organic molecules on Ceres with the impact history of the world. Researchers used the NASA Ames vertical gun range to bombard simulated Ceres samples. These human-made compounds look like what we saw in Ceres and are letting researchers try things we just don't have the tech to try at Ceres. Specifically, they are shooting things at the artificial surface at speeds of 2 to 6 kilometers per second with impact angles between 15 and 90 degrees. This is letting them test if small impactors, incoming micrometeors and their somewhat larger cousins, can break up the specific kinds of molecules seen at Ceres. They are then comparing what remains after impact with what is seen in different regions of Ceres. According to team researcher Tarek Dali, quote, "Although researchers have performed impact and shock experiments on various types of organics in the past, what was missing was a study dedicated to the type of organics detected on Ceres using the same type of analytical method used by the Dawn spacecraft to detect them." End quote. On Ceres, organics were found on older surfaces that also showed evidence of water. According to researcher Juan Rizos, quote, "We can see a very good correlation of organics with areas from older impacts and with other minerals like carbonates that also indicate the presence of water. While the origin of the organics remains poorly understood, we now have good evidence that they are formed in Ceres and likely in the presence of water." End quote. We currently believe Ceres could have subsurface reservoirs of water. And now Rizos explains, quote, "There is a possibility that a large interior reservoir of organics may be found inside Ceres. So from my perspective, that result increases the astrobiological potential of Ceres." End quote. Now, we just need to understand how hard or easy it is for organics to form into life. But that is research for the future. While asteroids are proving themselves more complicated than we expected, Mars, in a fit of publications, is also demanding attention for all its icy complexity. Back in May 2022, the InSight lander recorded a Mars quake with a magnitude of 4.7. While not all that large by Earth standards, this was the largest quake ever measured on Mars. This raised the question, was it caused by internal factors like tectonics, or was it the result of a meteor impact that shook the world? So a search was launched. Missions from the European Space Agency, the Chinese National Space Agency, the Indian Space Research Organization, and the United Arab Emirates Space Agency all combined efforts to search. According to a press release from the University of Oxford, quote, "This is thought to be the first time that all missions in orbit around Mars have collaborated on a single project." End quote. And they found nothing. This null result implies that Mars still has a bit of geologic activity ready to shake things up now and then. And those orbiting missions have plenty of science they can do when not searching for new impacts. For instance, data from the Mars Reconnaissance Orbiter, the 2001 Mars Odyssey, and the now inactive Mars Global Surveyor have been combined by a collaboration led by Gareth Morgan and Than Putzig to produce detailed maps of subsurface water ice on Mars. From potential buried glaciers to ice trapped in crater floors, this team has puzzled out where water hides, waiting for future tech and potentially future humans to come and mine it for use in habitats and as fuel for spacecraft. But before we put more humans on Mars, we really need to understand exactly what life may lurk, fossilized or not, in the Martian landscape. In a paper led by Alexis Rodriguez, researchers map out the flow of water and work to find some place where local life could have pooled. And in Mars' northern lowlands, they found just what they wanted in the hydrates chaos region. According to Rodriguez, quote, initially biomolecules could have been dispersed throughout the volume of large groundwater-filled cavities. As the water was released to the surface and ponded, the water went away, leaving behind lags of sediments and potentially high concentrations of biomolecules, end quote. Collaborator Mary Beth Wilhelm added, quote, NASA Ames is considering the plains as a possible landing site for a mission to search for evidence of biomarkers, specifically lipids. These biomolecules are extremely resistant and could have endured billions of years on Mars, end quote. A few episodes back, we covered how researchers have found ways to search for ancient lipids in sedimentary rock. This future mission could take what we learned to do here on Earth, look for lipids and other biomolecules that may still be on Mars. Here's to hoping this is research we'll see in our lifetime. As I said in the intro, we're recording this episode during our 32-hour Hangout-a-Thon. During a different hour, we're going to be interviewing some of the folks from the Mars Ice paper, and that interview will be brought to you right on our YouTube channel. Up next, we have Tales from the Launchpad with aerospace correspondent Erik Madaus and more. Stay tuned. Next up, I'm pleased to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launchpad. Hey, Erik.
Hi, Pamela. Since the last show, there's been some human spaceflight activity, with another routine crew flight from China to their station, in India completing a major milestone to their first crewed orbital flight. On October 21st, the Indian Space Research Organization launched the Gaganyaan abort test from the first launch pad at the Satish Dhawan Space Center in southern India. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
TVD1 का सफलतापूर्ण प्रज्वलन
Plus 5 seconds.
प्रथम प्रमोचन मंच से
Here we have a textbook liftoff of TVD1, a
seconds.
major milestone towards ISRO's Gaganyaan mission.
This launch was an in-flight abort test, which carried their in-development crew capsule to a specific altitude and speed to test part of its advanced three-part launch escape system. Testing of the system is very important to ensure crew safety during this flight, and is just the first of 4 in-flight abort tests ISRO has planned. This first in-flight abort test used just the smaller high-altitude abort motor that is integrated into the fairing around the capsule, which is used if something happens during the launch after the primary low-altitude abort motor is jettisoned during the rocket's second stage burn. The first test of the system, the pad abort test back in 2018, used both of these motors at the same time. The other 3 in-flight tests, including this one, will demonstrate escape capabilities in other phases of flight. To accelerate the capsule to its required speed and altitude for the test, ISRO used a modified side booster from the GSLV Mark II rocket fitted with an adapter for the much wider crew capsule. The first launch attempt on October 21st was scrubbed just after ignition due to an engine problem, but ISRO was able to resolve the problem and the launch took place about an hour later. The test was a complete success, with the capsule splashing down successfully 10 kilometers offshore under parachutes just a few minutes later. It was fished out of the ocean by a waiting Indian Navy vessel. ISRO hopes to launch up to 3 uncrewed Gaganyaan spacecraft into orbit next year, followed by a crewed flight test in 2025. An Indian astronaut is also planned to fly on a NASA commercial crew mission in 2024. And 2 potential ISRO astronauts are currently being trained at NASA's Johnson Space Center for the mission. On October 26th, China launched a Long March 2F carrying the Shenzhou 17 crewed mission to the Tiangong space station. The crew of 3 included 2 first-time space travelers, along with the mission commander, who was previously part of Shenzhou 12. Let's watch the launch.
2、1、 点火，起飞，起飞，机顶11114分，送2秒，491号秒，机顶11114分，送2秒，491号秒，
酒泉程序转弯，
程序转弯，
酒泉光学跟踪正常。
青山 USB 雷达跟踪正常，遥测信号正常。
6.5 hours after launch, they successfully docked to the station, joining the Shenzhou 16 crew, who have been in space for 6 months. The new crew will do the usual research previous crews have, but also perform maintenance on the station's solar panels, a first for a Chinese crew. They've been damaged slightly by space debris in the time the station has been in orbit, but according to engineers, they are still functioning properly. A few days later, the Shenzhou 16 crew packed up some research samples and undocked from the station to return to Earth. They returned successfully, though observers noted a small hole in the spacecraft's parachute. The capsule landed safely, but it was pulled over in the wind by the parachute after landing, something that is not uncommon with Soyuz-style spacecraft. Fortunately, the technonauts were unharmed by the experience and extracted swiftly after landing. Also during this time were 6 Starlink launches, 3 classified Chinese launches, and 1 classified Russian launch. We keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the USA has had 88 launches, China 51, India 8, Kazakhstan and Russia each have had 7, New Zealand 6, French Guiana and Japan each have had 3, North Korea and Iran, Israel, South Korea, and the United Kingdom each have had 1. Of these 179 launches, there have been 8 failures, reminding us that space is hard.
Thanks, Erik. Before we go, I'd like to share a bit of cooling news about our own planet Earth. Beneath California's eastern Sierra Nevada mountains lies a massive, dormant supervolcano. 760,000 years ago, the Long Valley caldera formed when 650 cubic kilometers of ash were thrown into the air in a rather terrible eruption. Today, this region is seeing swarms of earthquakes, but they aren't actually a sign of volcanic activity. Instead, as the magma chamber beneath the caldera cools, it is releasing fluids and gases that cause tremors. This work is described in a new paper in Science Advances led by Zhongwen Zhan. According to Zhan, quote, "We don't think the region is gearing up for another supervolcanic eruption, but the cooling process may release enough gas and liquid to cause earthquakes and small eruptions. For example, in May 1980, there were 4 magnitude 6 earthquakes in that region alone," end quote. It's good to know at least one of Earth's hotspots is cooling. This is your reminder. The Naples and Yellowstone supervolcanoes may yet one day roar to life again, hopefully in the far future. That's it for now. Good night, everyone, and remember, go out and look up.